How I purchased one item 6 different times, but ended up buying the same thing because of the false descriptions on the item. I want to tell you a quick story that might save you money and also save your electronics. I went online and searched for an isolated relay module. I saw many listings saying optocoupler isolated relay, full isolation relay, industrial relay module. So I bought one. Then I bought another. Then another. 6 different times from 6 different sellers. But when I tested them, they were all the same. All of them shared the same ground between the logic side and the relay coil side, which means they were not truly isolated. That was when I realized something important. Many products are described in a way that sounds professional, but in reality, they are not built that way. And today I will show you what isolation really means and how I built my own isolated relay module. If you want more tips like this, like and subscribe to my channel and watch this video to the end. Now let us talk about what isolation really means in a relay module. Isolation means there is no electrical connection between the control side and the relay side. The logic side is where your Arduino or ESP32 is connected. The relay side is where your high voltage load like a bulb motor or AC line is connected. True isolation means no shared ground, no shared power, no direct wire connection. The only thing that passes from one side to the other is light through an optocoupler. But the 6 relay modules I bought had something in common. They all share ground. The logic ground and relay ground were connected together. Some even shared the same 5-volt supply. So even though they had optocouplers on the board, the isolation was already broken. This is why many people lose microcontrollers when something goes wrong on the relay side. Next on my screen, you will see a video of how I created my own isolated relay module. In this video, I used an optocoupler, a relay, a separate power supply, and a driver circuit. The logic side and relay side do not touch electrically. I then connected a bulb as the load, and I wrote a shortcode that turns the bulb on and off every 2 seconds. On for 2 seconds, off for 2 seconds, again and again. This helped me test if the isolation really works and if the relay is switching properly. You will notice that even if something happens on the bulb side, my microcontroller is safe. Next on my screen is the circuit diagram. This diagram shows the optocoupler between the logic and relay side. You can clearly see 2 different grounds. One for logic, one for relay. I also added an LED on the coil side. This LED is very important. It shows when the relay coil is actually powered. Not when the microcontroller sends a signal, but when the relay truly turns on. So whenever the relay clicks, the LED lights up. This makes testing and troubleshooting very easy. Now let me explain why isolation is so important in a relay module. Isolation protects your microcontroller from high voltage. Isolation protects your laptop when connected by USB. Isolation protects you from electric shock. Isolation reduces electrical noise and interference. Isolation prevents damage when a relay fails. For example, if you are controlling an AC bulb from an Arduino and the relay fails, without isolation, the high voltage can travel back into your Arduino. Another example, if you are controlling a motor, motors produce noise and voltage spikes. Without isolation, that noise can reset or destroy your controller. Another example, in industrial panels, isolation allows different voltage systems to work safely together. This is why PLC systems and industrial relay boards always use isolation. So the lesson from my 6 purchases is simple. Do not trust the label. Test the circuit. Check if grounds are shared. And understand what isolation truly means. Building your own isolated relay module teaches you real electronics, not just plugging in ready-made boards. If this video helped you, like and subscribe.